Yeah. So I have a double loop here which calculates which evaluates f 4 times in order to calculate these 4 values here. Well, let's highlight this. In the end is a double partial derivative. And now I find myself in the need to extend that even. I want to calculate derivatives of derivatives of derivatives, and my god, let's automate this. Well, it has to be more flexible than this. Suppose I could just first calculate this. Could make a function that calculates the difference of two evaluations for a given set of values for E and C, where one of them, either E or C, and then some given index is incremented by delta, and the difference is divided by delta. But it's not just the evaluation that I need, because after that we need to do the same thing, but then on the whole. So we calculate this, where we have, well, here we have epsilon j plus delta minus epsilon, wait a minute, ci plus delta minus the f of ci. So we have plus delta, and then we subtract the thing without the delta. And then likewise, this has epsilon j plus delta, and then we subtract this exact same thing, but then without the delta on the epsilon j. And then I need to do the whole thing again, where one of the other variables is a plus delta and minus without the plus delta. How to do that? It must be some kind of a recursive thing, isn't it? Or is it? No, screw recursive. Let's just go for the direct calculation, as in not doing this, and then recursively subtract something that looks like it, etc. Let's just go directly for this. It's just a binary. I mean, we have two variables here, ci and epsilon j, and then all of them occur with or without delta added. And then it's like a binary, so here it's a 0, 0, because, well, we don't add any delta here. And then we add the delta just to ci, and here we add it just to epsilon, and here we add it to both. So in total you have 2 to the power 2 is 4 terms. And then the minus sign happens, I guess, whenever you have an odd number of deltas. Yeah, absolutely. So all I really need is a list of epsilons and coefficients, which I can store in, say, 2 vectors. Big cannon there using vectors for this, but well. Well, rather, I want to calculate this, this. Yeah, the thing has to return an imperial. Are we going to... We're going to need everything that we pass to F, so might as well just copy this. Well, possible, what as well, why not? And then we have to specify then what we take the derivative relative of, which would be, I can just pass it as a bit mask to begin with. Let's put it at the front. I don't know, should I put it at the end? Okay, I'll put it at the end. So I need a type that tells me, well, that is a bit mask, I suppose. I have a utility or a library, how you want to call it, of my own that deals with bits. Trying to think of that as more powerful, or if I need it. We need to toggle bits. We need to run over all permutations of the bits that are set. I guess I could ask Claude to write that, maybe. I'll pass 2 masks. It's kind of like a set of variables. Are they variables? Yeah, let's call them variables. The variable set contains the variables that we want to take the derivative. Well, relative to which we want to calculate the derivative. So this part now is going to be replaced with variable set constructed here past, and that well, yeah, okay, you can leave that away, I guess. We need something that allows me to construct it in a way that I know that I want to take the derivative relative to the epsilon j and the ci. Well, I guess I do that by I don't know. Let's just write it in a most logical, intuitive way. the epsilons. We have epsilons and we have coefficients. And the epsilons are j, in this case just one of them. And there's just one coefficient, something like this, right? This really doesn't matter. I'm gonna remove that. Is that nonsensical? Need a square. Yeah, I put the epsilon here, epsilons up front. Don't ask. Why? Oh, it's ij. Okay, let's put the coefficients up front. Oh, wait a minute. I really never have to take the derivative relative to two epsilons. I'm gonna have multiple coefficients, but definitely not two epsilons, right? I mean, why would I want to do that? No, I don't want to do that. I don't want to do that. I don't think I want to do that. No, it would be nonsense. So it's kind of silly to even allow that, as it were, because it's nonsense. So this is a coefficient set then, but just one coefficient, I. And the second one is the epsilon, if any, I guess. Okay, now this is the inner thing. Let's define that one first. So we need a class called coefficients set, which takes an integer or one or more integers, or maybe even zero integers. Yeah, why not? Which then represents all the possible coefficients as a mask. So 0 or more coefficients. I might as well do that all the way at the top, I suppose. I'm gonna call this a struct. And it kind of depends on the number of coefficients. So, well, that's 4. So I should probably use a type def, or what is it, using coefficients as well. Some type which gives me the number of coefficients. Yeah, and then the same thing we have for the epsilons. That would be this one then. So I only have 11. Now, of course, you have to do that everywhere. It was 12. Coefficients. Yeah. Epsilons. No, screw the comment, it's just exactly the same. Okay, so now those are the coefficients and epsilons. But yeah, I'm not going to use a bit set here. Unless I want to use my own bit stuff. Do I have a bit set? Yeah, I have a utils bit set. So I might want to use that. Set, bit set POD type. It is literally just a mask. I think I want to use this. 'Some unsigned integer. Yeah, I guess 16 fast type, if that even exists. No, let's do 16. 16 should be enough, well, right now. Okay, I'll just make it 32. Plenty of room there. Need a default constructor that fills the thing with zeros, meaning that if I use the default constructor, I just don't have any coefficients at all. Let's see what the current thing is doing for the default constructor. Uninitialized, yeah, that's not going to work then. I guess I should use this one. Or I can construct it from a bit set POD if that exists. That is 0 already. Yeah, I have to make my own, I suppose. We can construct a bit set from a POD. I don't know what to use here. Just use that. And then we have one that takes a single integer. I'm starting to think this is, yeah, I mean, theoretically I could use a template with a random number of integers and then yeah, right. But yeah, this is local to this file, and I think I only passed 2 or 3 maybe. So might as well do it this way right now. So that would be the coefficient index. I'm just gonna call it index. We have only one. And then the mask must be filled with, of course, no, into mask I. And then I can add a whole series of these things. For now I only need 2. Oh, wait a minute, I have support for indexes. I should use indexes here, not int. Bit set. Yeah, index. That's the whole point, of course. God knows how that works. So instead of int, we want to use index. Where do I get that index from? Oops. Utils index. That's something else. Man, I have too many indexes. Try that again. Utils bit set index. I wanted to go with this one. That can be constructed from an index POD, which in turn can be constructed from an int, I suppose. So this thing takes an index, but if you pass an int, then it better works. If you pass an int and it needs an index, it's probably going to construct an index, I think. And then we don't need an into mask anymore, because of course my mask can be constructed from an index, right? Don't need this anymore. Or is that the case? Can bit set be constructed from an index? Yep, here construct a bit set with a single bit set at, here's the index to mask, so we're using the one that we already had now. But then we have 2 of them. That's slightly different. I guess now I first need to turn them into a bit mask. This thing is so big. Where's the index anyway? But of course, what namespace I mean. Is this in a namespace? Bit set. Utils bit set. So that's a bit too much. Let's add it here. Let's add it at the top using index is utils bit set index. So we can abbreviate the thing. Well, actually, likewise, I wanted to do this one. So do the using bit sets is that. So then we can create just a bit set here from the I0 and OR that. I mean, a bit set can be ORed. Pretty sure about that. No, this is construction. I don't know. Let's use braces for construction. And then this is more like initialization. So I don't know. I haven't decided yet what is best. Yeah, both work. So sometimes it's annoying that you can do the same thing multiple ways. Right, and this is then passed to the last argument of a derivative of f, which is a variable set. And yeah, really that's more or less the same thing as the coefficient set, except that I'll use a class. No. The size of this thing. Is the size of an array static? Well, it should be, because this is just a constant, like a const expression constant. Maybe it's not even a function. No, it is a function, but no, we'll discover it, I guess. So, okay. Till, huh? Till, not including. We'll use the minus one. Let me fix my music. Yeah. Chosen constructor is explicit in copy initialization. Yeah, that looks silly. I guess I will just have to do it like that then. And why not? Only non-void function does not return a value. Yeah, I didn't implement that yet. No matching constructor for initialization of coefficient set. So this is not true. I think that the reason that it's not true is that it's explicit, just like the other one. Kind of makes sense. Kind of makes sense. So, like I said, we will see, and indeed, it's not possible. So the bit set index cannot be implicitly constructed from an int. You can only construct it from an index POD. Or obviously from another index. It's just a copy constructor. Yeah, why would I use ints at all? I just have to use the index everywhere. So this these loops here should be indexes as well. It's just an index. Index I. Now this index is running from 0 till the size of C. It would be super nice if I had an example here, and I don't. I have plenty examples in other code, but find that back. I hate that so much. This is one of the latest pretty large project is still Linux Viewer. Maybe that one has it. Running over an index. Nope. That one does not have it. Well, it's part of utils. I should just go to the test suite of utils. The test suite surely has it. For index. Yeah. Oh yeah, right. Right. It's only one? Yeah, you have to use I begin. I had completely forgotten that. Though that would be inside something that has I begin. Oh no, that's an array, a utils array. I could use my own array, utils array, and then define the index of it. You can set the type of the index as the bit set index. That would work. Yeah, there is also another way to just run over bit sets indexes, of course. Oh, here it is, index begin. Or not. That looks like something. Linux sure does have something related to bit sets. Let's have a look in Linux viewer anyway, again. Damn it, I just can't find it. It looks like I'm making it myself very difficult here. Because why not just use an int, right? But it's exactly because it is so difficult to get it to compile that it is so much more powerful than an int. There is a good reason that you have to go through all this trouble. Because it's resistant against making errors. So you have to be really specific. Now in this case, I have two indexes that I can confuse. This is the same type as that one. While this is something totally different. This is the index of a coefficient and this is the index of an epsilon. I could fix that as well. I have arrays and vectors in utils that for which you can specify the type of the index, which is then also wrap around an int, but it has its own type. So they could use a different type for this one and for that one. I will be even better, really. Maybe I should do that. I'm starting to have the feeling that that's definitely what I should have done. Maybe I should do that, yes. Shall we do that? Yeah, well, depends on how many viewers I have. If I have 5 viewers, I don't see the viewers. So if I have 5 viewers, I'm definitely going to do it, just to show you what is the correct way to do it. And if I have 3 or less viewers, then I will not, because, well, then this is bad coding, but as long as it works, right? And unfortunately for the people that are watching, 3 viewers. So I'm not going to do it yet. Just try if this compiles. There. Yeah, what? Okay, that doesn't make any sense. Imperial is defined here, and then we get an error. Talking about what? Oh no. Never mind. No mention construct over initialization of imperial. What is this talking about? Oh. A missing variable. No mention function of call to derivative of f. Cannot convert initialize list argument to const variable set. This cannot be passed to a variable set. Why not? Coefficient set, comma e. Oh, that's an. No, wait a minute. The j here. The j is now in the index. Yeah, well. Oh, I didn't add a constructor at all. Okay, the constructor is. What was it taking? Coefficient set, of course. And then I think there must be an index in. An epsilon index. Base class. And the member. No variable conversion from bit set index to int. Yeah, because this is an index. We no longer use ints, we use indexes. And then we get immediately the problem that if you want to use that index as an index in an array, that it doesn't work. Of course, we can convert the index to an int. It's not as difficult as the other way around. Let's see where that is. Yeah. Just adding two parentheses. What was it here? I think this J is still oh no. It's just, this is printing. Er komt baas. Okay, so back to the beginning. This has to be replaced with a new call, derivative of. And we just pass the exact same thing as that we have to pass to each of these f calls here. It's the same arguments. And then we have now a variable set, which tells us which epsilon and coefficient to tweak. Right, okay. Not to implement that thing. Hello, wiki kebab. Okay, now I'm hungry. Damn it. No, I'm just kidding. Problem. I'm thinking about if I want to ever not take the partial derivative relative to some epsilon. I mean, right now we construct a thing by passing an epsilon index to the index can be undefined. That's not a problem. I mean, it's not an int. No? Now it's a powerful Carlo-Wood written index. So it either has a meaning or it has not a meaning. Now, if it's -1, then it has the special meaning that it's not defined. So if we don't want to take the derivative relative to some epsilon, then we can pass an default constructed index, which is then undefined between quotes. Or am I confused now with, actually I'm confused with the array index again, array and vector index. But this one does have a special value, doesn't it? I have a pre-begin, could use that. I mean, as long as it's -1 under the hood. No, I don't know. Maybe I should pass end instead. But again, probably not going to do that at all. I think I have to always need an epsilon to differentiate against. But I feel like I have to support empty coefficient sets, so not take derivatives relative to coefficients. But not both, you know, not. Now I think about it, why not? I mean, might as well. So if this thing is empty, and this then is either empty or it has one element, and empty being then, let's say, equal to end. It's just special case that. So don't we got rid of it. So if VS, the variable set, is empty, to have to define that now. Then we don't take the derivative relative to anything at all. So in that case, we just return f with everything that was being passed. Shall I make a static delta or probably maybe it's called capital delta. Who thinks of that? I'm gonna make it lowercase here. No, it was 24, wasn't it? And it's not capital. But it is 24. Let's try that. Just non-constant. Okay, so what we want to do is have a result, which is something. We begin with 0. So let's define the thing as 0. And then of course we return that. And then I have to actually I want to, in the end I have to divide by the delta. I think you can do the power. It should use argument dependent lookup. Can you look up, or how do you say that? Get it from the MP of our namespace. So it's like standard power, but then one defined for this library, for the MP real thing. Results to the power, the number of bits set in the variable. So let's call it size or bits or variables. No, size. It's a variable set. So the size is the number of variables. Except that is of course not the result. No? This is delta. Now we better check if this compiles, I think. Yeah, I didn't have an empty yet. And no size. You need an empty and a size in the variable set. Size type. I hate size type. Plus the thing is never going to be any larger than just int. Size const. Return something, and then here we do simply return size equals 0. Haha. The laziness themselves. Okay, I can speed this one up a little bit. So if the epsilon index is unknown, then maybe it is, you know, this must definitely be unknown. Undefined, I think, not unknown. Index, bit set index as an oh, it doesn't. Yeah, right, it doesn't. And again, I was confused with the other one. Thing isn't as powerful as I thought. The only thing it really supports is jumping to the next bit data set, which is what I'm going to need it for. But still. So let's use index end as unknown. So we call the same variable, the same function on the base class. And then if this is equal to and, then we add nothing, otherwise we add 1. And then now I have to implement empty and size in the coefficient set. Okay, that would be this bit set. If the bit set equals 0, then it is empty. Surely this thing has a boolean somewhere. Wait, this is a bit set, yeah, none. We have a count and something else. This thing is a lot more powerful, the bit set itself. Anyway, none means that no bits are being set. So this would be return the none on the mask. And the size it has to be the number of bits. So we had a pop count for that. That's what it is. So yeah, pop count. There it is. Simply count. It's called count here. Oh yeah. Mask. Shall I rename this one to count? Okay, I'll do that. Index int requires template arguments. But yeah, we don't like code duplication. So if I have it here, it would be better to steal this from the bit set here. So if you have the bit set, then that type is given by the mask type. The which is public. The mask type of bit set. Now that's going to be enormously annoying now to pass no epsilon at all. But you can make that, of course, a default here. Let's do it like this. So I don't pass an epsilon index at all. It's going to use this construct here. It's a bit set index end, which then will result in that this is going to be true. Well, not really, but this is. And now we add 0. Another one. Yeah, it compiles again. Well, the only reason I was trying to compile it was because I wanted to test if the power works, but I guess it does. Okay, now we have to add to result the value of f after, well, running over all possible permutations of adding or not adding delta to each of the coefficients and the epsilon. I think I'm going to do the epsilon separately because or do I? Let me think. Itchy. Oh, Zoom. It would take a damn long time, man, to install CDEH. I'm just kidding, but you should have told me. Well, the last thing we spoke about is I told you you're gonna need it anyway, so please install CDEH and then tell me when you're done. Then we can continue. And I think 2 weeks passed, so now I forgot what it was that I would tell you afterwards. Or should tell you. Well, you could have installed it in 10 minutes. Well, an hour. Okay, let's not exaggerate. 1 hour would have been more than enough, I think. So how do we run over all permutations of all set bits? Maybe you should just store all the bits in an array and then run over all the permutations of the index of that array. Otherwise, I don't really see an easy way to do this. Okay, let's do some thinking out loud, as in comments. So if all the bits are just contiguous, so just these are the bits, or the bits are set, right? So I have a few bits set, and I want to run over all possible permutations. Then we could do meaning, you know, like all zeros or all ones or. And so on. So that would be just counting. Now the question is, what happens if there is 2 zeros in between here? What kind of counting are we doing then? I could fill this with ones. This, and then ignore it. But yeah, maybe. I mean, you add 1 here, and then the moment you get an overflow, then these 2 ones immediately overflow as well. So this one is 1, this one is set. That should work like should totally work. Except then afterwards I have to set those again. So we need to invert the mask. I could invert the mask, like so. And then we start with that mask, and then we start with that mask, so like that, and I add 1, and then I OR with the mask. And then we add 1 and OR with the mask, and add 1 and OR with the mask. And then add 1, and then OR with the mask. So that should work. But that works for yeah, that works for that mask for this one. Sorry, for the coefficients. Yeah, everything is kind of. I can hide all of that inside variable set. Let's just pretend that it already works. Then how would this code look like? So we do VS, and then we do begin, and then we do increment it, and some kind of loop state. think I need a state for it. I mean, that mask was a state, but it could be stored inside a variable set. I'm just going to do begin permutation. Begin permutations. Going to need a loop as well. I guess a while loop or do while. Just a while loop. I like while loops. While something. The something is actually easier. So we do a result plus yeah, the evaluation of f at the current x C is arbitrarily large. So C is constant. Could make it non-const. Apply, restore is maybe the best. Yeah, begin permutations. I guess we just pass the coefficients and the epsilon. And then here we can do VS, and then we get the coefficients. And the E and the what. Begin permutation, and then we add evaluations of f with total control over the coefficients and the epsilons. And number of times also controlled by the variable set. I think this should work. I mean, it should be possible to implement it. You should think so. Which requires 4 new functions. Namely, begin permutations. I can't remember that, so I'll just copy everything. Convergence, epsilons. Can't find the pattern. Sorry, that type was... oh, that is the same as coefficients, actually. That is just an array. Whoops. Yeah, these are just arrays. These 4. No, the last 2 I used here. And the first 2 I used here and there. Now we need to change the array, so we need to make a copy. Otherwise you can't return that. So really these are just accessors. I should not define them here maybe. Well, who cares? An accessor, yeah. Typically something that you would put inside the class itself. Yeah, I think this is just going to return a copy of the array. So that these abbreviations are absolutely ridiculous. I'm not going to call my class members single character stuff. Epsilons, and these are coefficients. Let's just put that here. As accessors. Yeah, and then these things, yeah. Big arrays, but what can we do? And then if begin permutations is called, might as well add that here as well now, I think. I'm not sure though, wait a minute. Let's not do this too hasty then. I need to make a copy anyway. So the begin permutations begins with copying into that. So the coefficients is simply, yeah, coefficients then. Epsilons. So we make a copy of them, meaning that none of them has a delta. Which means that we don't know if we need we don't know if we need a minus sign in this case. We need a sign as well. So sign. Sign question mark -1 or 1. Might as well be an int then, huh? Yeah, it depends on the size, which is already defined at this point. So the size is the number of variables. If the number of variables is odd, wait a minute, yeah, we need a sign of +1 in the case every variable has delta added. So if none of the variables has delta added, then that is a minus if and only if we have an odd number of variables. So we could do %2, and if that equals 1, then we do this. Okay. Upon doing the next permutation, the sign must be inverted. Oh, wait a minute. Is that true? No, it's not true. That is not true. No, it depends on whether or not well, it depends on the number of set variables, the number of variables that have delta added again, which is the number of bits that we have set. Maybe I should just invert, maybe I should just leave sign alone and change it here, and in this one it's kind of going to return minus sign or sign. Which depends on, so if no bits are set, that was the beginning, that was sign. No bits is an even number of bits, so if an odd number of bits is set, then we need to return a minus sign. Yeah, except that I don't want to change these things really. We have to remember them. Ugh. What am I doing? It's not correct. Yeah, I think it's better to first add the variables that I need to check. I'm starting to regret it that I used the bit set, because I'm not going to use it to run over the set bits. Okay, so let's define the epsilon mask as, I think it's even a cons expression. So shift it to the left with a number of coefficients. It's just initialize current mask with 0. Nothing set. And the unused mask is then the inverse of a mask which has bits set for everything that is used, which would be equal to the mask in coefficient sets, but now we have to add the epsilon mask to that if epsilon is being used. Yeah, I can just calculate it, I think. So in the begin permutations, we are going to continue with calculating the unused mask, which is equal to the inverse of the mask in the base class, right? It's got variables. What the hell? These are the coefficients that are being set. These are the coefficients that need to be, that we need to take the derivative with respect to, that are being used. And I need to get the value of this, just get the value. That's I should get rid of the whole bit set, I think. Okay, I think I'm gonna get rid of it. It's just making it confusing now. No bit sets. No bit sets. So the bit set itself is just uint32 type. That's maybe a bit much. Let's use a bit set. It's just bang. Int 32 type. Of course, you don't have an index. The index is now just an int. Yeah, then I do need int to mask. Ugh. I'll just copy it. Let's call it mask instead. Nah, they're just ints. I'm going to use int here. What the hell was I doing? I lost track. Oh yeah. Okay, so when a variable set is being constructed, it sets a coefficient set and an epsilon index. So the coefficient set now has a coefficient set mask as mask. And I want to access that, but this is struct, so whatever, mask underscore of the coefficient set, which is the mask underscore of the variable set, and we have an epsilon index. And then this must be the inverse of that. And then if the epsilon is not used, then we also want to set as unused the epsilon mask bit. And we can figure out if the epsilon is being used or not by the fact that if it isn't, then it is -1. I didn't fix that completely. So being -1 means that it is not being used. And then again, where I was editing, which of course I forgot. Somewhere down here. Yeah. If, oh god, I didn't copy it, equals -1. Epsilon index. It was epsilon index. So the epsilon index is set to -1 because it wasn't passed to the variable set. Then also the epsilon mask is being unused, yeah? Which is simply the bit that comes after all the coefficient bits. And the coefficient bits are, well, part of the base class here, coefficient set, which is simply constructed by passing 1 or 2 indexes. So now I have initialized the unused mask, I hope. The current mask is set to 0, well, why not? And then Yeah. Then we have this while loop somewhere. No, I don't have a while loop there. Well. There's a while loop. That's all that I meant. Next permutation, yeah. So as long as any bits in current mask are set, then there is a next permutation. And then after the last one, this becomes 0. Why? Because I'm going to increment it after ORing it with the unused mask. So the thing started with all zeros, and we set all bits that are not used, and then we increment it, which means that the least significant used bit is now being set. And by the time that all used bits are set, then if after this all bits are set, and then after an increment it's 0. Therefore we will return false. Yep, and then the only thing left is that while we're doing all these permutations, we have to update the variables accordingly. Oh shit. Suddenly I do need my index. I mean, I kind of need to run over the bits, the set bits. No, I'll find another way. Yeah, I'll definitely find another way. I first need to find a place where I want to do this. I think the begin permutations begins with all bits unset. Cut mask is 0. This means that we'll just leave all the variables alone. So we begin with the evaluation or all the coefficients and the epsilon, or all epsilons, or just whatever they are. And then we come in next permutation, which then sets the first variable. Sets it here. So we have definitely only exactly one bit set here. Unless, of course, no, that would be this case. So there's at least one unused bit. sorry, at least one used bit, and that used bit is now set after the first, the least significant one of that, after the first increment. I can do with current mask what I want as long as I don't touch the... No, I cannot, sorry. Well, it's 0 now. If it is 0, and it needs to be remain 0. So I can reset bits. I can reset unused mask if I want to. That would be okay. So we can do resets. Oops. Reset the bits again. Yes. And now the only bits that are set are the ones that we where we have to add delta to yeah, to the corresponding variable. We also have to reset it again. So the stuff, I think upon a return we should start with resetting it. So if any bits are set in current mask at this point, then those need to be reset. I could just copy everything, but it's just things that, I don't know. I really don't want to copy loads and loads of imperials. Well, only one of them is changed. But theoretically I would run here over all set bits. And then for each bit that is set, restore them. And here we do the exact same thing, and except of restoring, we add delta to it. So I don't need a delta here. But that would be code duplication. So we do this here, and then we do it again. Maybe we should do this in a loop. So you could make a loop, size 2. We do this once, and then we do this, and then we do that, and then we exit. So really it's more like if L equals 1, or if L equals, yeah, 1, break. No need to do that. Yeah, no, just have to treat the epsilon separately. So if the epsilon mask bit is set, then the copy in epsilons is restored to the original value. Well, if L equals 0. Otherwise, if L is not equal 0, then we have to add delta to it. And then we have to do the same thing for all the coefficients. If the bit is set. And we need an index, so we might as well run over all indexes. So it's the coefficient index running from 0 to the size of coefficients. Maybe I should just use the same for loop as I did here. Epsilon uses J and coefficient uses I. So yeah, I'm gonna use this. I don't think I use a delta here anymore now. Nope. So let's remove this delta here. Or comment it out as well. Okay, using that. Oh boy. Now I added that, so I can't jump back. So annoying. Okay, let's just use let's just use I therefore. And then we can simply copy this code, right? If current mask and then we have here a mask. The guess index 2 mask is going to work, I hope. Let me see, the index of mask is part of the coefficient set, yeah, which is part of the base class of the variable set, so that should work. And here we use then the coefficients. Oops, C, I, coefficients I plus delta. I think we're done. So let's see if it compiles. Of course, they are not done until it compiles. Yeah, renamed that to 0 mask. It's kind of silly now, of course. Mask underscore, which is a mask, which is an int. No, really, no, I don't really need that anymore. Member reference type, base type count mask. Oops. Oh, yeah. Well, I'm just gonna call pop count directly. Find that back. Yo, utils list, and we pass it. Bit set here. Just pop count. Always there's an underscore there. I think it should just call pop count. Oh, need a header. Okay. Yep. More bit set stuff is remaining. None means of course that this thing is equal to 0. Coefficient size. Call to a non-static member function without an object argument. No, it's probably something else then. Let's look it up. Standard array. Yeah, what ridiculousness. The size of an array is totally compile time constant. Totally. Why would I not be able to extract it from the type without an object? I don't see it here. Ridiculous. Oh yeah, that one. And what is this sign? Derivative of. Oh, wait a minute. Yeah, that's kind of weird. This should be part of the variable set, then shouldn't it? But. No, it shouldn't. No, that is dirty, but it's just test code, so I really can't spend more time on this. Why is private? I told you it was dirty. Let's make it public. Oh, it's static anyway. Static and const. Totally can be public. Oops. Compile. Oh, there's more. No. Now it compiles, so it works, right? Finish the code and it compiles. Don't think it works. Nope, doesn't not really work. These are big numbers. These are weird numbers. It's just not working. Fortunately, I have to go to bed, but I played a game, chess game, over the board today, and I have to analyze it because I made a. I should have won this game. Damn it! I got into time trouble. Not really, because I had 30 seconds every move. But yeah, I don't know what happened. I don't know. So like I said, I should have won this. I totally should have won it. Analysis boards. I had black, so I'm gonna turn this around. Flipboard. Let's turn this on. My opponent played e4, and I thought half an hour, and played c5. Knight c3, and I played knight c6. Is that theory? That's possible. It is totally possible. g3. I thought that was a weird move because he already played this. He just immediately makes a hole here. And he completely commits to playing the bishop here. While this is indeed a logical move, I would say. And as you can see, g3 is not mentioned. So I think I'm better after this. No, it's equal. Okay, anyway, I immediately screwed up, of course. I played d6. Yep, white is better again with the 0.1. And he did it. He did it. He went behind his own pawn. Now I'm better. Mine is 0.1. So then I thought, where are we? Bishop, yeah. Let's do the same thing. But in my case, it's the best computer move. I mean, you have all those pawns here, right? And this bishop has to play. And if you have the knight and the pawns on this diagonal, then this is the diagonal where you want to play over. So here, plus I did not play this pawn, right? This square isn't immediately like a weird squeak. At least that was my argument here. And I plan to put my bishop here and then play this pawn forward and make this bishop a beast. Yeah, that's the plan. Yeah, that is g6, knight g to e7. Yeah, why? That's possible. Definitely, but suddenly it's the best move. Shit. Okay, he was still in the theory. Just kidding. You play d3 here. I mean, this square has my name on it, so, and he wanted to develop that bishop. Rook b8. Yeah, the moves like this, even though there is an error here, it's kind of, oh, it's the second one on the list here, so it's not that bad, but more or less fancy. Okay, like I said, bishop here, I want to play these pawns up. And this is still more or less on the diagonal, you know. So if I play this pawn up, then my knight is not protected. And that means that if he plays this pawn, I definitely want to be able to take here. Instead of having to move my rook then as an afterthought. And here my opponent played a4 instead of castling. Yeah, and if you wait long enough, that becomes the computer move. And I played bishop to d7. Because this bishop has to be developed, I thought. Later I wished I had put it here, but on the other hand, this is not a move. I mean, you don't know. And of course I could put it here, but then he would just chase it away, right? I mean, here he's gonna play this pawn anyway. That would be a complete waste of time. I don't think this bishop can go anywhere else. On the other hand, it was equal. It's one of the lesser moves, if you can count 0.1 as a lesser move. Okay. And my opponent then played the bishop to e3. Definitely also a lesser move, right? No, it's the second on the row. Yeah. Still, no, it's 0.0 again. Oh! Is it? No, anyway. He had to develop the last piece, so kind of makes sense. And so did I. And here I had a feeling that I did play knight to f6, but I really did not like that, because it blocks my bishop. And where does this thing go afterwards? It doesn't even threaten anything. The place to be is here, or here maybe, because then I can follow up as soon as I can play the knight here. That would be nice if then this knight was here and they follow each other. But yeah, I felt I had to castle. I did contemplate to go here, but what future do you have then? He could still play this pawn up. It's not like I can go from here to there to there. After he is doing that. So the nice thing with this position is that I can put my knight on d4, and he can't take it with his knight, because then take with the pawn, with the fork, and I win a piece. So then I have this knight here, and he can't chase it away because this pawn is blocked by that knight, and he can't take it. And I just have a strong knight. Plus then I definitely threaten to play my bishop here. But yeah, development comes first. I definitely could have continued with the plan on this side. I mean, you have to play this pawn and then play that pawn. But I felt like, yeah, dude, you have to develop a castle before doing that. So I'm kind of surprised that this is the best move. Anyway, so I did this. No, I'm not super disappointed, actually. I thought it was worse. It's not super bad. So again, maybe 0.1 is a big difference at most. My opponent looked in his lap, and then he played the best computer move. No, he didn't. At least I didn't notice. This guy is playing a lot of computer moves though. So here I played the best computer moves. Oh, not anymore. And that's h6, a6. Oh, I did. I castled. Yeah. Very good, Curlo. And my opponent castled as well. Also the best move. We're playing like grandmasters. a6. Still the best move. And yeah, that's what I played. Finally. Then the queen came to d2. Also a computer move. And then I played... Seriously? Oh, this is the first time I do a move that doesn't have an arrow at all. Yeah, I should have continued with this plan, of course. It makes sense. It does make sense. Okay, I did this, and I'll tell you why. Holy... What the blunder! The only reason I did this is because... That's no longer possible. Did I do that? And I didn't. So I didn't. Wait a minute. No. I played. I know I wrote it down correctly. Knight e5. That's what I did. It's still not really good. But the reason I did this is simply because now I'm threatened to take here. And I thought, well, initiative can't harm. He's probably going to play f4. And then I'll just go back, and then I thought that would help me somehow. Because then this pawn becomes weak, or I don't know. Just to me it felt like if my opponent comes forward with the pawns, then his king position is weakened. And he's totally going for this square, right? He's going to attack me here. So he's doing this. So he did that. Of course he did. Computer move. And then I did this. I went back. So now he blocked his own bishop. Is that an advantage for me? Yeah, white is now plus 0.4. That was not a good move. Inviting f4. And here he played g4. And I started to feel I was losing, because this suddenly starts to look very, very dangerous. And I don't think I can defend it. So there was only one thing I could do here, I thought. And that is have some counterplay on the other side. So I played... After g4, actually, I did not play b5. I played... Oh shit. I played a bad move? Yeah, I played a bad move. Oh no. Oh, I played a really bad move here. e5. Yeah, this is losing. +2. Maybe after this move, maybe now I started to feel like I was losing. Okay, now I went here. Yeah, I'm definitely losing here. So he can't take here because that loses a piece. And he definitely has plans with this bishop. The plan is to go here. Definitely. And then get rid of this defense here. I think the king attack that he's doing is something that he's very familiar with. Very familiar. He's done this a million times. So he didn't want to exchange the bishop, of course, and he also did not want to exchange knights. He felt that my knight is not doing much here, and he can need a knight on this side, so he played a knight over here. And then finally I woke up, and too late I played b5. Should have played the bishop, I see. Yeah, here I definitely had the feeling that I'm losing, and rightfully so, apparently. Even though there's not a pawn or a piece from the board yet. It's purely strategically a really bad position. So I tried to do something on the other side. And I took back, of course, and then I took with the pawn. I don't know why. No, it's +3 for white. Oh, so horrible. The funny thing, however, is that doing this on this side made my opponent nervous like hell. And I think if he would have just continued attacking, like he was, and completely ignoring this side, then he would have won. So yeah, just push, 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 and I'm dead, I guess. But for some reason he thought that he did not have enough pieces on this side, and he wanted to double the rooks. So he played rook f2, which was the whole point. No, it's only +2. And I played b4, because I had a plan. And then we got knight from c to e2. Let's see, if we went here, then I would have taken it, yes. +1.4 would still have been difficult. But yeah, he played this move, the computer move. And I played, and he said that this was the first move that he had not anticipated. It's not even that good move. Penalty, but okay, I played b3. The idea being that I'm now threatening to go here, even if he pushes the pawn, saying I go here, the rook is attacked, And then I get rid of this bishop. And then after that I should be okay. Let's say he does that, and yeah, I'm okay. See? Then this is the best move, and then this is the best move, and this is the best move, and this is the best move. And now it's drawish again. So at least I saw that. And yeah, you should just ignore it. You should just attack here. But he got so nervous. Knight takes d4 was played. And away is all the advantage of white. And now the obvious move is to go here, pin my knight, and then threaten to take here, getting the rook into the play, while it is pinned, and I can't defend it. There's no way it's just this defended twice. There is no way I can defend it again, another time. And the rook comes behind. I mean, what am I going to do? If I does this? Okay, I play here, and now. Okay, I should take it. Oh, I'm pestering the bishop away before he can take here. Okay, I just... But it's still the best move. Instead, he continued with the plan that he had already executed a billion times, I think. And he went here. And then I took here, as any computer would do. And the bishop takes g7, king takes, obviously. And he played g5 instead of taking the pawn. Now finally he plays g5. I mean, that is the way to attack. But apparently he's used to going here with the bishop, exchanging the bishop, and only then playing this pawn. It's a way to attack, I guess. Well, that's interesting. I promote to a queen. No, I don't. I played the computer move. I mean, the alternative. Well, this is really bad, I think. So if I go here, he takes it, and then I take back, and then it's so totally exposed, right? That can't be good. This is draw. Just take it. I take back. Wrong position. And this one seemed very bad as well, because then he pushes this pawn. And now this knight is trapped. I can never go away anymore. I did think for a very long time though, because if I go here, now my rook is more or less trapped. So I go here, and of course he pushes the pawn. Of course he pushes the pawn. This is a really weird move. Oh, he wants to take with the rook and then do something on this side. Okay. And defend that one for the matter. No, he first played here. Now I am better. -1. I went in the corner, and then the queen took here. Now it's suddenly the better move to just take. And here I came into serious time trouble. I had 5 minutes left maybe. And we still have to do 16 moves before the move 40 was reached. At which point we would get to half an hour extra. Yeah, I needed more time than I had in total. So I had to play faster, and I couldn't decide. Yeah, I definitely felt like knight here, there is like it's super good. Knight has to play it anyway because the rook comes in here. Just naturally flow everything to this side. But I was seeing ghosts. I was super scared about this pawn coming up and again coming up and then taking here. And then I don't know what I saw. But if this, I don't know what I saw. I mean, it's obviously not very clear. But I thought that perhaps by the time it started to become scary, really scary, that it would be too late. Because this is, of course, a very, very, very weak point. I can't defend that at all. It's definitely not when the knight is gone. Sorry. So what I wanted to do is say... fix everything. For example, I could do this. Let's say I do this and he does that. Now everything is fixed. And well, it's not super bad for black. And then I have all the time in the world to get my knight over here and rooks over here. And I'm a pawn down, I think. No, I'm not a pawn down here. Just yeah. However, yeah, if you go here, I thought he would sacrifice the knight, indeed. And then I don't have any defense left. This is completely blocked here. All those pieces, they're not playing on this side at all. And this is like 1-2 moves to get this rook involved on this file. Oh, let's see how that works. So he takes. I'm not even taking back, can you imagine? Just a full pawn then. So if I do take back, queen comes in. No, I'm already dead. That's what I mean. There is no way to defend this. Yeah, this is dead. See this is the problem here. That suddenly you're dead. This is just finished. So that's what the kind of thing that I was scared about. So what I wanted to do is make room. I mean, I need a defense on this file, because if I don't do anything, let's say I do nothing, and he starts walking, and I do again nothing. I don't want him to play on this side. Let's play on this side. How often do I have to do nothing before I'm starting to lose? I can take back like that. If I take back like this, then what happened? Then I'm dead. Okay, interesting. But I can take back like this. Ah, now this blockade is... Oh, if I take like this, then the blockade is gone. And now I can use all my pieces, 2 rooks if I want to defend this square and this square. Yeah, taking like that is the solution here, of course. And he's not going to promote anytime soon, I guess. But it is a free pawn. Kind of sucks, but still. Draw. It's a draw, this. Okay, so I had plenty of time, because now I did nothing all this time. I did have plenty of time to do good moves, like develop stuff. If he plays this, I do nothing. And if he takes, I take like that. Yes, yes. Now, yeah, anyway, I played h6 with the idea that if he takes, then I take this one, and he's gonna lose that one as well. And this file's blocked now with 2 pawns on it. And if he doesn't take, say he defends it, then my king can come forward, and then the rook can come here, and then the king can go there, and then I open that file myself by taking here. If I push it all the way there, there's nothing to take, right? But if I put it here, I'm threatened to take. Take. But the only way I can do that is if the knight is still eyeing this spot here. I need to be able to take this pawn. So I could not first develop the knight and then push this pawn. I had to do it right now. And I really didn't like it, but yeah, time pressure. I had no time to think about it. So my advantage is now gone again. And my opponent played, he took it, strangely enough. That was really strange. I don't know why he took it. This can't be good, right? Well, why make a double pawn here and give away that one? Yeah, it's just -1. Minus 1.3. I'm winning again. So obviously I took it, yeah. But he gets a pawn, he gets another pawn. That's not, yeah, I didn't even consider this, to be honest. So he's going to take this pawn as well. And I see now that I should have gone here. So he takes, and then I just take the rook. And then he has to take back, of course, and then I take that pawn. And then, yeah. Then he's one pawn up? No, I'm better here. It's strange. 1, 2, 3, 4, 5 against 5. No, he's not even going to win a pawn then. He took a pawn and I took a pawn. Now I'm going away, and then he takes a pawn, and then I take a pawn. Well, after exchanging rooks. Well, time. I didn't have time enough here to think deeply. In the end, I went here, I guess mainly because I want to defend my rook, which is silly. Defend the whole line here. And then, of course, he took. And then I decided, oh, wait a minute, I better take here. So that at least is a good move. Because, yeah, I had to take, kind of. And now I want to play... Where are we? Rook. I wrote it down wrong. I think I forgot to write down here also. I just didn't have time enough. No, this here. The rook takes f7, the rook takes f7, the rook takes f7. And then we get black plays bishop e6. And he went there, which is the best move, so I won't put a lot of time into that. And then I played... Yeah, I didn't want the queen to come in, but why not? I would just exchange it. I did this move, still time pressure. Queen to a4. He played queen to a4, which is a blunder again. Yep. Now you understand what I did. I played, no, I played this, the best move. And I'm totally winning. Totally winning. How annoying is that? So he played queen a5 and I was like, yeah, okay. Thank you for that pawn. And then he played rook to c7. And then I played rook to f8. And then my opponent played queen to b6. And I'm so winning here. It's too sad for words. I did not give check, I went here. I don't know why. No, did I give the pawn away? Oh, I want to defend this one, so I'm like, well, okay, you can have that one. Okay, you can have that one. Yeah, this is a bad move. I'm blocking my knight. This is the place where my knight should go. This is the move. Keep the tempo, he can't take here. He goes somewhere. Yes, if I had a lot of time, I would definitely have. I thought about this. This is the logical flow of attacking pieces. How is he going to defend it? He just isn't. I'm threatening so much now. But I did not. I felt I had no time to think about what happened with back rank checks. So if I do this. You know, you see something like that, and then what do? Yeah, go back, yeah. Oh, it can be defended. Yeah, okay. No, I missed it. But that's because if you have to do your move in 30 seconds, then you get that. I would have needed 5 minutes per move at least. To actually do all that. So here I played pretty stupid move. And then the opponent played this, which is again -3. I should again play this. Same thing. And again, I didn't dare to do that. I just didn't dare to allow him to give check with so little time. It just, yeah, I should have seen that I can play the bishop back. And the knight there, I should have seen that. That defends everything. Everything. Yeah, okay, anyway. What was the last move? King. I thought I didn't want to win anymore, I guess, because I had to put my rook. I had to defend this ball. This is just not having any time. That's really. And my opponent again, you know, was making hand signs to his friend on the other side of the room, and he played this. I thought it was the best move. And now the worst thing happened ever. The worst thing. Because I blocked my knight and suddenly I don't have any attack anymore. So, fuck. And no time. I put my rook on a stupid square. We still had to do 5 moves here before I could start to think again. In order to reach move 40. So I played this because, yeah, as soon as the queen comes here, I have to play it anyway. It can't go there. And this, at least, it's doing-ish attacking. Maybe I can go there, or I don't know. And then he played rook to e2. And I didn't see this. Unbelievable. Time pressure, nerves, I don't know. I remember I thought, how can this happen, that he suddenly attacks my bishop, and where can I go? I could have played the bishop. Oh, I couldn't. My rook is attacked, sorry. Yeah, it's a discovered attack, sorry. So he played the rook away with discovered attack on my rook, and at the same time attacks my bishop. Yeah. So now I have to play the rook, and I was thinking that the reason that this is happening is because the knight blocks my queen, so the queen is not defending my rook anymore. That's what I was thinking. How stupid do you have to be that you don't see this move? Check, and it's finished. It's just finished. Well, by this time there were like 10 to 15 people around the table, so I guess one of the last games. And most of the people saw this, of course. Team members later said, well, I thought you would see that. He just knew I would see it. No, I didn't. I have no idea why. This is so completely won. And then I would have won. But yeah, because I did not see this move, I had to give away a piece. Really, I had to go away a piece here. So I played the following brilliant move, which indeed is a draw. And that all in time pressure. And my opponents thought I didn't write this down, damn it. I think he took my piece, right? And I'm winning. I'll play it here. I'm fucking winning? You gotta be kidding me. Shit. Shit. The idea, of course, that if he takes here, I take here, and he's mate in 7. You know, this is finished. Undefendable. So in that sense, it was a brilliant move. But he went here. And then I played this move, because attack on the rook and the knight. So he has to take it, right? And if he goes here, I just take the rook. So he takes it. And then I took like this. And then he went there. I'm flabbergasted. I offered a draw here. No. Well, I don't know. If you get 30 seconds every move, then there's plenty of time to think. But once you get in this mood of I don't have time anymore. Oh my God. So I went here. He went there. I went there. He went there. And now we reached 40 moves. Or 42 or something. Yeah, 42 moves. So by now I realized that I would get time. So I had a half an hour now. Half an hour and 2 minutes or something like that. So I could really start to think again. But I felt, you still feel in this mode of I'm losing, I lost a piece. The whole time pressure thing, and the only thing that I saw was I'm gonna go for infinite check and get a draw out of this because of that. Then I asked a teammate, in this situation, I asked a teammate, what is the score? And he said the draw is enough. So if we would get a draw here, then our team would win. It was, what was it? 3.5, 2.5 then? So no. The end score was, yeah, the end score was 3.5, 4.5. So it was 3-4. So we would get a draw, the team would win. And after he said that, I gave check and I offered a draw, and my opponent immediately agreed. And I had not realized until this moment that this is just completely winning still for me. I'm disgusted, really. This is too sad for words. Half an hour on the bloody clock, and I did not sit to think. Why did I not sit to think with half an hour on the clock? Just because there's some lingering thought of having a lost position and I'm lucky that I have an infinite check. If I had not asked this question, if I had not asked what is the current score, stand? I don't know what is that in English. I would have given it obviously more thought here, and then maybe have seen this move. No, I'm really disgusted here. Really, really disgusted. This threatens a mate so fast. There is nothing. He cannot do anything here. Oh, this is bad. Oh my god. This is really no fun whatsoever. Yeah. If he does something, I don't know. It's forced mate, right? He just has to do that. Put the rook here and then I take there's mate. Oh shit. Oh shit. Shit. This is even worse than I thought. I did offer a draw in a completely wrong position. Oh my god. I feel about as shitty as let's say losing 3,000 euros on the stock market in one day. If that is comparable. Major suckage. Oh man, this is bad. Okay, I have to go to bed. I'm going to bed. I'm going to bed in -2 hours. It's way too late. Okay, yeah, I have to go. Good night, people. Yeah, it's midnight, but I should go to bed earlier than midnight because I'm not going to sleep. I have to play with my phone, watch movies. Before you know it now, it's going to be 4 p.m. before I fall asleep.